Now let us look at the next problem. For the resistance network shown in the figure, choose the correct options. Okay, so here we can see that this circuit diagram is very close to a Wheatstone bridge. Okay, because the ratio of resistance in the two arms, respective arms, that is this arm and this arm, is 1:2. Similarly 1:2, and here also it is 1:2. One more thing is that from output input symmetry, that instead of current passing in this direction, let us say if we reverse the polarity, then current would pass in this direction. Then from input output symmetry, so the current that is flowing in this direction will be same when the polarity is reversed. Okay, because it is symmetric in both the cases. Now, since this is similar to Wheatstone bridge, we can safely say that potential of point P will be same as that of potential of point Q. That means there is no potential difference across P and Q, so this 1 ohm resistance is of no use. It is just a showpiece. It becomes redundant. So we can ignore this. Similarly, we can ignore this 1 ohm resistance because potential of S and T would be same. Now this 2 and 2, they will be in series, giving 6 ohm as effective resistance. 4 ohm, 4 ohm and 4 ohm again will become in series, so the net is 12 ohm. Let us say the current I1 is entering into the circuit and this is I2 is passing through 6 ohm and I4 is passing through 12 ohm. Then since the ratio of the resistance is these two, 6 ohm and 12 ohm, they are in parallel, ratio of their resistance is how much? 1:2. Therefore the current would be inverse of this ratio, that is 2:1. Okay, now what is the effective resistance of the parallel combination? 1/R is equal to 1/6 plus 1/12. This will give us R equal to 4 ohm. Now 12 volt battery is connected, so current I1 that is passing through it is 12/4, that is 3 ampere. Now 3 ampere current is divided in the ratio of 2:1. That means I2 is 2 ampere and I4 is 1 ampere. Okay, now if we, let us say we take the potential of this point, negative terminal, as 0, and then we traverse from this point up to S in this fashion, then the potential of point S will be, so when we move across this, there is a gain of 12 volts. Then across this there is a drop of how much? 2 into 2 is 4, and then again 2 into 2 is 4 IR. So we will get this as 4 volts. So the potential, absolute potential of point S is 4 volt. Similarly, if we find out the potential of point Q by traversing in this direction, then the potential is 12 volt. There is a potential gain first, then there is a potential drop, 4 into 1 IR, that is 8 volt. So point Q is at higher potential and point S is at lower potential. Now based on the discussion, now let us look at the options that we have. The current through PQ is 0. No current will flow through this because it is equipotential. So this is correct. This current is 3 ampere, that also we calculated. The potential at S is less than that at Q. True, because the potential difference of Q is 4 volts in comparison to point S. And option D is I2 is 2 ampere. This is also correct. So all the 4 options are correct.